teaching. It became the standard, which I have never come near to. But I've certainly taught a lot of students because I took over the introductory epidemiology course for the school. And so I've taught some 6,000 students for whom you get a lot of the credit for whatever they learned because I followed as much as I could your inspiration. What have I given back to David in return? I gave him an autographed baseball from the Brooklyn Dodgers, signed by, among others, Jackie Robinson.
So we're hearing all these things about David as a teacher at work. That's nothing. What you have to hear about is David at home. David can tell you the starters every day for the Brooklyn Dodgers and the pitchers and their statistics for every year, certainly in the 50s and probably in the 1940s, and he's right. David can tell you the starting team and some of the secondary players for the UNC Chapel Hill basketball team from, when did you go there?
Started there 66.
So from 1966, but he learned some of the ones earlier than that. He knows all of the teams, all the players and their statistics, and he's accurate all the way till the present. He's right. And Phil Grazer is here, wearing an appropriate shirt. And Phil and Leslie have a house right near Piedmont Park, where the Peachtree Road race used to stop. And so David taught himself to play the saxophone, and he did it so that as the people left the Peachtree Road race, David could play the Star-Spangled Banner over and over again for the people who are coming through. So he not only can know the names of students, but he knows a lot of other things as well.
We'll move on then, and we'll give David a few gifts. And then we are going to hear from David himself after that.
This is from the Department of Epidemiology. He said he had too many chairs already, so he didn't want a chair. And instead, we got a computer.
This is the latest iPad. And the first iPad didn't have PowerPoint or a Word or anything on it. The latest one has all that on it. So it's like really having a computer that I can use. Not in there? This is where there's a story. Maybe it's not in there. Oh, it might be within there. There's an app in there. An app, you know, attached to your computer. I don't know where it is. Somewhere. Where's that? With wishes for a happy retirement from your colleagues and friends in the Department of Epidemiology, Rollins School of Public Health at the University.
Oh.
The other thing that is maybe not in here, but it's somewhere. It's an app, and compared to this computer, it's really cheap. But it's something that I really could use to help my music, help my get better in music. And the name of this app is the Amazing Slow Downer. The Amazing Slow Downer. what does that mean? What do you think that means? What is it slowing down? Well, you know, if you're trying to learn a piece of music, and you're trying to learn it, and it's a difficult piece, and it's actually fast, and you're trying to learn to play it at the speed that you would have to play it if you're playing out in public, you have to play it at that speed. Particularly, you have to play it with your other musicians who can play it at that speed. So what the amazing slow downer does is it takes whatever piece you're trying to learn, you put it in there, you click on something, and then what it does is it plays that piece at a slower pace. It slows it down. But the thing that it does that's actually really special is it slows it down, but it keeps the pitch. So if I want to play, if it's in F, the key of F, and I want to play it in the key of F and I slow it down, it's still in the key of F. I mean, if I slowed it down and it didn't, you know, normally it would change the key. And I couldn't play it. I'd be playing some like a dirge or something. I don't know what. But that's what the amazing slow downer is. And this is something I'm very, very happy to get.
Now we have the real surprise.
Real surprise?
Lord.
Oh.
So I think many of you would agree that there is no shortage of outstanding mentors at Emory. And I've been really fortunate to have had David as one of mine. I had the privilege of interacting with him in a variety of different contexts as an MPH student, a doctoral student. I TA'd for him for 2 different classes, joined the faculty and became his colleague, and was most recently very humbled when I was asked to step in to teach epimodeling in his retirement. And those are really big shoes that feel impossible to fill, but I'm doing my best. And many of us have hidden talents or ways that we like to spend our time outside of work. We know that David likes to play his jazz flute. One of my favorite things to do is to sew. I find it very relaxing, and have been doing much more of it since the election. Has helped me calm down a little bit. And as I was browsing one day, I ran across something that I knew that I had to work on for David as part of his retirement celebration. So I enlisted the help of 2 of our alumni, Angela Miller, who was an Epi-PhD student, and Sharia Ahmed, who was an MPH student, and created something for David that captures 2 things that he really loves. So. It's math and equation
She's the next great teacher.
Now a few words from David.
Word for me? Oh, one more gift?
One more.
Okay.
Yeah, from the students. And we don't care if you have enough shirts because we're giving you enough.
Oh.
This is for all the students. Yeah.
Oh, and that's,
And
a
that's,
note.
yeah, all the notes. You can read them later.
Then I'll go to this. If I get this to work. Hello, can you hear me? Is it loud enough? So what I want to do is just sort of talk about my, sort of give you a personal tour of my life, what I've looked like over the years, and some of the things I've done. And so you see pictures of me at various ages, you know, even when I was really young. just to show you how I've changed. Of course, I've changed. My hair gray. When I started, it was gray. I didn't even have hair. So let's see. If I want to make this move, okay, so now the first thing is, that's a picture of me when I was in elementary school. PS 197, Brooklyn, New York. You notice the pompadour? People wore pompadours back then. I don't know if they do it nowadays, but I had I grew up in Brooklyn. I went to James Madison High School from 1954 to 1958. Among the other graduates of James Madison are Carol King. She was in my class, and her name was Carol Klein. And so she was right near me in the yearbook. Well, not that way, but anyhow. Bernie Sanders went to Madison. He's actually, believe it or not, he's younger than me. And he was in the class behind me, and I never met him. Never met him when I found out he went to Madison, the class behind me. And then there's Ruth Bader Ginsburg, who's one of my heroes. Now, she was not in my class. She's at least maybe 15 or 20 years older, but she's one of my heroes, on the Supreme Court. They all went to Madison. I went to undergraduate at a small college, Hamilton College in upstate New York. Very cold up there, very cold. Not that cold here, up here. I also was in upstate New York to get a master's in mathematics at the University of Rochester, in Rochester, New York. And then I went to UNC and got my PhD at the University of North Carolina Mathematical Statistics Department. So the PhD was in mathematical statistics. It wasn't in biostatistics. And in fact, the thing about those 4 years in my PhD program, I didn't like it. I mean, it wasn't fun because I never saw a number during those whole 4 years. And I went to graduate school in statistics to try to learn how to analyze data and to be able to see numbers. And so eventually, during the time I was a graduate student, I got to know about that there was another school on the campus called School of Public Health. And they had a biostatistics department, which also had an epidemiology department. And I got some kind of a fellowship to work with somebody in the School of Public Health during my last 2 years as a graduate student, and that's how I got introduced to public health and biostatistics and epidemiology. So the mathematical statistics part was, that's how I got my degree, but I learned my epidemiology and my biostatistics while I was a faculty member at the UNC School of Public Health, starting in 1970. And I was at UNC from 1970 on faculty until 1993. From 1993 until now, I've been here at Emory. I've had a couple of years of sort of sabbatical trips. I was in Australia for 2 years, nice place. So anyhow. And there's a couple of pictures of me in my youth. Sailor suit, sailor boy, cowboy, okay? What is this, February 1947, okay? The year that Jackie Robinson was introduced. Here is some more pictures. Here I am with a pompadour. Here's a little bit later. And one early sign, as I said here, is I've wanted to teach ever since I was a little kid growing up in Brooklyn, teaching some of my neighborhood friends how to play card games, later checkers, and still later chess. In fact, and I remember my mother telling me a long time ago that I was destined to teach. So I learned something early on that was, So what's this? Recognize anybody? Well, that's me in 1971 at UNC, and I'm teaching a course in regression analysis. It's a second level regression course. And in fact, up until 1970, the only course that was required of MPH students in Chapel Hill was basic biostatistics. We started introducing second-level biostatistics in 1971. But if you notice this picture, well, first of all, there's me with beard and a little younger, a little different looking, and you notice that there's chalk on the blackboard, right? And back in those days, when you were teaching statistics, particularly mathematical stuff, you were teaching statistics, the only way you could do it, given what was available, was to write on the blackboard what you were teaching. The students would write down what you wrote on the blackboard on a pad that they had, and then they'd go home and try to figure out what you said. And to me, that was terrible. And that was the way most of mathematics stuff was taught. I mean, other stuff like if you're teaching English or history or something, a lot of faculty went in and they had slide projectors, and they came in the room with a slide projector and they put it up and then they talked about what the slides were coming. But to teach math, that wouldn't work because it would be hard to sort of understand the formula without having something that this is what you had at the beginning. In fact, I even sort of invented something. I don't want to really say I invented it, but exactly. But at some point I said, there's something about this that's bothering me, about this, chalky blackboard. What's bothering me is, again, the students they're just getting to write it down, and then they're taking it home, and they're trying to learn it, and they're not getting to learn the material as the class is going on. So what I invented, so to speak, was the handout. The handout. Did I invent the handout? No. But I brought the handout. I started bringing I created handouts that was going to be about what I was teaching, and I brought it to class. So they had something. They didn't have to write everything down. They could take the handout and make notes on it if they wanted, and then they could go home and look at it so that they could actually concentrate on what I was doing if they were able to, if I was communicating okay. So I invented the handout. Did I invent that? Or like, what's his name invented the internet? Al Gore invented the internet. Now, here's another thing. When I was teaching, the first several courses I taught for a number of years was in introductory biostatistics for MPH students, not for biostatistics majors, for MPH students. And the most difficult part of that course for people to learn, which usually they never really wanted to be there in the first place because statistics had a terrible reputation for being boring and horrible teaching and stuff, good teachers and stuff. So anyhow, the worst part of the course, the most difficult part of the course to learn, it was at the beginning, and it was about probability. What is probability? And how do you use it, and how does it make sense? And it was always, I don't know if you remember this, but do you remember permutations and combinations, learning about that? And when you started learning about it, you would get these questions that the teacher would give you, and you couldn't figure them out because they were too complicated. So I came up with this idea to develop a teaching module that would teach what probability was all about in the context of sort of a realistic example that had to do with data, and could teach what the rules of probability were about and actually give them something to lead into what they're going to learn later. So this was a module that had something like 15 slides, and the slides were sort of complicated. You notice that this is the first slide, and you notice there's two things on it. These are covers or something that had to be turned over in order to see what was underneath them. But the first thing that they would look at, they'd see this picture, and I'd say, well, what's this picture? What's in this picture? And then they'd say, well, it looks like there's a bunch of people. Okay, yeah, it is. And how many people? 20, if you count them. Okay. And if you actually think about it, and you were trying to do some study about what was going on with these people, you notice that some of them smoked. Where? Yeah, I can't see it too well. Somewhere out
there to the right.
And some of them had little dots on their lungs. So some of them had some kind of a lung problem. Maybe it was lung cancer, I'm not sure. So then I'd ask them, well, okay, how many people smoked? And they'd count the number of people who had cigarettes in their mouth, and it'd be 9. Okay, well, what does that mean? Consider the fact that you have 20 people you're starting with. So 9/20 was the proportion of the people who smoked, and that's an example of a probability estimate. So I was introducing probability through this example. And then I'd say, well, what's the probability or the probability estimate that somebody would have lung cancer? If that was what, well, what's the probability that somebody would have both lung cancer and smoke? And then we got into the whole thing about, well, there's a whole bunch of different ways to talk about this. What about if they have lung cancer and they don't smoke? Well, when you talk about that, what you're trying to do is you're trying to take the data that you have, this is a simple form of the data, and put it in a sort of an array so that you can see what the data was sort of saying. And the array was what we call nowadays, what most of us in this room call nowadays, a 2x2 or a two-way table. So you could take this data and put it in a two-way table. And so I did that. I opened up these slats over here, and eventually I showed what was in the two-way table. And then I said, well, what can you do with this table? What can you do with it? Well, in this case, the question of interest, whether there was a relationship between smoking and lung cancer, in some sense. Those are the two variables that were being dealt with. And so I built a whole teaching module about how to talk about how you would get that relationship. And in order to do that, I had to bring in rules of probability and teach rules of probability in that context. And eventually, at the end of the whole module, at the very end, I showed a 2x2 table with some different data that was real data that described the relationship between weight and something else. I can't remember, weight and ulcer evidence or something like that. And it had a 2x2 table with numbers in it, and what I eventually showed was how you would take those numbers and combine them to compute an index which would describe the relationship. And what was that?